Okay, so we looked at section 1.1 last time, right? And we derived a couple of formulas. So we said the distance, right, between any 2 points, we could use the Pythagorean theorem, and we derived, right, this formula. So you don't have to use the Pythagorean theorem or prove to me, you're just allowed to go straight to this formula, but it helps if you know where it comes from. We also talked about that, right, when we're reading a graph, we're reading points on the x-axis, right, we want to read right to left because you want big minus small, and then we're reading on the y-axis, we want top to bottom, okay? So the other thing that we kind of didn't get really to touch on in here was midpoint, right? So what if you want to find the midpoint of any line segment? So if you're looking at a horizontal or a vertical line, right, it's pretty easy. You could just chop it in half and then add that half to either endpoint, and that'll get you to the middle. But what if we're looking at some kind of like slanted line? So when you want to find the middle of something, all you do is average the x values together and then average the y values together. So that's actually giving you the middle. I mean, that's what the mean or the middle is. So whenever you want to, if you want to know, right, what your test average is in here, since they're all equally weighted, you would just add your 3 grades together and divide by 3. And so that's the same idea here. And if you're in the 3-dimensional coordinate system, which you guys won't see in here, the midpoint would be average all the x values, average all the y values. So then you would divide by 3, right? Because you'd have three values to look at. So one of the things, or I'm sorry, in the XYZ plane, you would have an X, a Y, and a Z. Sorry, my bad. And you would average those together. So that's all the midpoint formula is. And the reason I want to kind of put that idea in your brain is because when you're trying to remember these formulas, you'll notice that a lot of times we're taking the difference of the coordinates, and this time we're taking the sum of the coordinates. So if you have negative values, you have to remember, like if it's, you know, let's say 2, -3. Let's do a quick example, right? If I have 2, -3, and let's say -1, 5, right? Well, I'm still going to add, and when you add negative numbers together, it's going to look like you're actually subtracting, but we're actually going to add them together. So you would have 2 plus -1, right, over 2, and then -3 plus, right, 5 over 2. So I'm still adding them, right? That's why we want to make sure we're keeping that straight. If I wanted to find the distance between those 2 points, well then up here there's a subtraction in the problem, so it would be 2 minus -1, so that it would end up being added together. So the reason I want you guys to make sure you're paying really close attention is on exams and on quizzes and on things on the basic skills test. They love to throw negatives at you, especially in this stuff, and making sure you're handling your negative signs properly. All right, so the last thing that's in this section that's kind of a no-brainer, I don't want to like spend a lot of time on it because we're going to work with functions later, is but on ALEKS you'll see they're going to throw problems at you in this section, and what they want you to do when they talk about plotting a function, right, is they want you to make the table of values, plot the points, and the little graphing utility in ALEKS actually lets you do that. It'll make you plot 5 points and then connect the dots. But what I want to do now is we want to move on to section 1.2, and we actually want to talk about circles, okay? So circles are actually not functions, and we're going to define a function in the next section, but just keep that in mind that a circle is not a function, okay? And so we'll get into that in just a second, all right? So section 1.2 is going to be all about circles. And so let's start out by defining what a circle is, okay? So a circle is the set of all points, right, of the form x, y, such that all x, y are a distance r from a fixed point, not a sick point, a fixed point, h comma k. Right? Where hk is known as the center and r is the radius. So I like this definition because this gets to the point that I was making about things like on the exam. So by simply literally drawing out this description, you can kind of see where a circle is coming from. So if you look in here, they mention the word distance, so the distance formula is going to crop up, right? They mention that we have a fixed point, right? And that we're at some distance r away from that point, and it's all fixed points. So did any of you guys ever in high school in geometry actually get to use a compass? Right, not a north, south, east, west compass, but an actual compass, right? You put a pencil in, you have the point, right? That's how you would draw circles around. So if we take a fixed point, and I'm terrible at drawing circles, I'm going to apologize in advance for this, but if we take some fixed point, HK, right, and we go out a distance r, right? So there's an xy that is r away. But if we want all the points that are that distance r away, right, we would, and it should be a solid line, but I can't draw circles very well, so I'm gonna dot this, and it's a wonky circle. But the idea is if you stretch this r, right, all the way around, everything on this dotted line here is a distance r away from that fixed point, and that's where you get a circle, okay? So if we want to come up with the standard equation of a circle, well, let's start with our distance formula. So the distance formula, right, says you say x1 minus x2 squared plus y1 minus y2 squared. Now in theory, it doesn't really matter which x or y you put first, right? Because we said they're the same. We went over that on Friday. However, when we're talking about circles, the convention is make x1, y1 the point on the circle itself, and then we usually make x2, y2 the center or the fixed point. So if I plug in all the information I was given in here, it says, well, the distance is r, so d is r, right? I'm going to leave my square root. And I'm going to leave my unknown point x is just x, right, minus h, because that's the x coordinate of the fixed point, right, plus y minus k. So we just call them x and y because there are multiple x and y's, right, that lie on this circle. Actually, there's really infinitely many, right, because we can keep getting tighter and tighter around there. So that's a really ugly equation, right? We don't really like to have square roots if we can help it. So if I want to get rid of that square root, you just simply square both sides of the equation. So now, this is the standard form of a circle. And the reason we like these standard forms, the whole point of getting it in some kind of, like when we did y equals mx plus b for lines, right? The whole point of these standard forms is that I can look at the equation and immediately extract information out of it without having to do any calculations. So one thing that people always tend to kind of mess up is don't forget that this is r squared, right? And the reason it is r squared is we don't want to deal with the square root. So make sure if you're looking at the equation of a circle, you know to take the square root of that number to get the actual radius. And also look at the form of h and k. So those minus signs are actually in the standard form, right? And we know now why they're there. They're there because they came from the distance formula. So one of the things that's cool when you're pulling the center of a circle out is you'll notice that the coordinate points of h and k will appear to change signs, right? So let's look at an example of a circle. So if I'm looking at this equation, the center of this circle should be HK, right? So when I write the center, the negative sign is actually in the equation itself. So the x coordinate is 3. The y coordinate is -2, because what this actually is y minus -2, and that's how it becomes a +2. So one of the kind of shortcuts that students like to think of this as is it's not really changing signs, but notice when you pull the center out, the signs are the opposite of what they are in the equation. So if you have a minus in front of the 3, it comes out as a positive. If you have a plus in front of the 2, you pull it out as a negative. Does that make sense? So that's one of the things you want to make sure you can literally just pull the center out. And the radius here is 4, okay? But I can absolutely promise you that some of you on the basic skills test will tell you to say the radius is 16. So don't do that. It's the square root. And so one of the things that they'll do to you is rather than giving you a nice perfect square, right, they could say this equation equals something like 45. Well, then you would just say the radius is square root of 45. And you don't have to really simplify it from there. But just make sure you know that you're taking the square root. All right, so if we give you the equation of the circle, right, you should be able to pull information out. The flip side is, right, what if I don't give you the equation, but I want you to write it for me? So let's say we have a circle centered at -1, 5. And a radius of 3. So if you know the standard form, right, you should be able to just pop this information in and get the circle. So this will be x plus 1 squared, right, because the sign's going to flip back just like it would flip when you pull it out. And this will be y minus 5 squared, and it will equal the radius squared, which is 9. So notice in both of these problems, right, the center in the equation and the center when you look at it on its own, right, the signs are opposite. Do I see that? Okay. All right, this isn't meant to be crazy hard. Okay, so I have an example I want to do with you guys. All right, so let's look at an equation of a circle in a non-standard form and figure out how to put it in standard form. So if I were to give you the following equation, right? We want to find the center and radius of the circle. So in order to find the center and radius of the circle, the easiest thing to do is to rewrite the equation in standard form, okay? And so in order to write this in standard form, we're actually going to have to do, which some of you may remember this from high school, we're going to have to actually complete the square. Because what a circle is it's a term squared plus another term squared equals a radius squared. So there's sort of a technique that I like to do when we're doing these. It kind of makes things a little bit easier, hopefully. All right, so the first thing you want to do if you're trying to put this in, and also let me tell you another thing. So the tell that you have a circle is, notice you have an x squared and a y squared in the equation, okay? The 2x and the 10y are not important. They don't have to be there, right? It's the x squared and the y squared. So whenever you're looking at anything that's got both of those things squared, that's the first clue that this is a circle rearranged, okay? So imagine in this case somebody's taken the circle out of standard form, foiled out the squared terms, and rearranged things, and that's how you ended up like this. So we kind of have to undo that, right, to get back. So if the y wasn't squared, then you could say we're probably dealing with a quadratic, but that y squared is why we know it's a circle. So the first thing you want to do is you want to group the x's and the y's together. And another way I could have written this is this plus 7 or minus 17 here could have been plus 17 on this side equals 0. It would have been the same equation. So the first thing you want to do is you want to group all the terms with an x, right, on one side. Group all the y's. Notice I'm leaving a space here. And then we would move any constants over to the other side if they weren't already there, okay? So in order to complete the square, what I have to do is I have to figure out a number to plug into each of those spots, so that way that term would factor, the quadratic factors into something squared. So one of the mistakes, and it's not really a mistake, but one of the techniques people do that tends to get them into trouble is they tend to do it line by line, okay? And then what'll happen is they'll figure out how to complete the square, but then on the next line when they go to factor, it's like in their head they think they got to factor from scratch again. So the whole point of this is you are deciding what goes into that spot. So the factoring should be obvious, all right? So what I do is I tell people to do the two lines at the same time, right? So we know that this needs to factor into x minus something squared plus y minus something squared, okay? So we can actually do these two things in the same step. So here's what we do. A quadratic, right, is usually of the form, right, ax squared plus bx plus c equals 0. And what you want to do when you're completing the square is we want to add b over 2a squared, okay? So in this case, a is 1 because we don't have any coefficients in front of our x or y squared. So really all you're going to be doing, and 99 times out of 100, there won't be any numbers in front of the x or y squared. So all we're really going to do is divide the middle term by 2 and then square it and add it to both sides. So notice the plus sign and the minus sign. The sign down here in the circle equation should match the sign up here. So I actually know this has to factor into x plus something, right? So if it doesn't factor into x plus, when I FOIL it out, I'm not going to get a middle term that's positive. This guy's going to stay negative. So if I divide this by 2, I get 1, okay? So the 1 goes here, right? Now square it and add it here. So if I add a 1 on the left side of this equation, then I need to add a 1 on the right side of the equation. The next one, right, divide the middle term by 5. And so here's the idea here, guys. If I FOIL this out and I add 1 plus 1, I'm going to get 2. Because remember, when you're FOILing out something squared, the outside and the inside terms are the same. Okay? So over here, if I want to get to 10, well then I had to add 5 and 5. Because you got to be adding the same number twice because it's a squared term. So when you divide 10 by 2, right, we get negative 5. So that means this is y minus 5, right? If you square negative 5, you get positive 25. So if I add 25 to the left, I have to add 25 to the right. So we actually can factor and complete the square at the exact same time, okay? So then, what do we need that top line for? Well, I have to make sure whatever I'm adding on the left, I'm adding on the right. So if we simplify the constants over on the right, we should get positive 9. And so now we see that the center of this circle is negative 1, 5. And the radius is 3. So, completing the square takes a little bit of practice, but I have really found that this technique helps. So, like I said, the old school way of doing it is people would just do that line, and then they would have to come down and figure out what this stuff factors into, and everybody was just kind of forgetting the point. The whole point of completing the square is making it factor into something convenient for you, right? So if we actually FOILed out x plus 1 squared, just to kind of show you where this is coming from, if I expanded, you can always check yourself with math. That's what's kind of so great about it. If we were to expand this out, right, that would be saying do x plus 1 times x plus 1, right? So if you FOIL this, you'll get x squared plus x plus 1, and voila, we get exactly what we wanted. And so this is what I was getting at about the factoring into something squared, right? The outside terms and the inside terms are going to be the same when you're FOILing a squared term. And so that's why all you have to do is chop the middle number in half, and that's the thing you added up twice to get there. Okay? So even if we got really lucky and these were even numbers in the middle, right? But even if you had an odd number, like if it were x squared plus 3x, right? Well, then you would say divide by 2, so that's 3 halves. So then it would be x plus 3 halves. And then you would square that number and get 9/4, and you would add 9/4 to both sides. So you can still do this even with fractions, right? But that's the technique. Divide the middle number by 2, then square it and add it to both sides. All right, any questions so far? No? Okay. So let's take a quick second and let's talk about semicircles, okay? So I'm going to give you a spoiler alert, right? So the reason we say circles are not functions, all right? We're going to spend a lot of time on this, but a function, when you graph it, has to pass the vertical line test, right? So the rule is, in order for something to be a function, if you plug in any x value into the equation, only one y value should come out. If multiple y values come out, we say it's not a function. That's algebraically how you tell. But graphically, the way we check for that is we just draw a vertical line, and if you can slide that vertical line across the function, it should only cross it once at any given time. So a circle, just kind of by the nature, right, if we draw a complete circle, well, then we can see that it clearly fails, right, the vertical line test. Okay, so if you remember back in high school when you probably used TI, graphing calculators, and you wanted to actually plot a circle, we actually had to type two functions into the calculator. Because if you solve an equation, a circle equation for y, right, because the calculator would only let you put things in the form of y equals, well, you're going to have a y squared equals some stuff, right? Well, the only way to get that y by itself is to take the square root of both sides. And you always need to remember, when you're taking the square root, what you're really doing is producing two pieces of information. It could have been a positive thing that you squared, or it could have been a negative thing that you squared. So if we want to look at a really simple circle equation. So what's the center of that circle? Two's the radius. What's the center?
0, 0.
0, 0, right? So whenever you just see x squared plus y squared, 0, 0, the center is the origin, okay? Because what we've got here is, we're not going to write it out, but what this is saying is this is the same thing as writing this, right? But we don't write x minus 0. That's silly, because x minus 0 is just x, right? So this is a circle centered at the origin, right, with a radius of 2. So if I wanted to plot this or graph it in my calculator, I would have to solve it for y. So if we get y squared by itself, and then the next step is to get y by itself, right, we take the square root. Well, what I actually produce is this. I actually get two answers out. Because I don't know if that squared term was originally positive. I don't know if that thing I squared was originally negative. So you have to account for both. So when you see an equation with a radical, right, and a constant number minus an x squared, that should jump out at you that that is actually a semicircle. So the positive case is the top half, right? That's the top half of the semicircle. The negative case is the bottom half, right, of the circle. So that's why in high school, when you actually wanted to graph a circle, we had to graph both of these equations, and it didn't always graph it very pretty, like an exact circle, and there was this little gap there, but it just looked like a little egg, but you would have to graph the top and bottom separately. So we expect you to recognize the equation of a semicircle when you see it. If you want to go back, or you're not sure if you have a circle or not, if we started with this equation with the radical, well, if I squared both sides and moved the x squared over, then I could in fact see, oh, this is a circle of radius 2. So the other thing to keep in mind, you can always remember which is the top and bottom half, because if y equals things that are positive, well, y is always positive above the x-axis, right? If you've got y equals negative square root, right? Well, those numbers are all going to come out negative, and y is negative under the x-axis, right? But who says we have to solve this equation for y? We could have said, well, I want to solve it for x. So if we were to solve this same equation for x, you would see that we would get x equals plus or minus the square root of 4 minus y squared, where the positive case is the right half of the circle and the negative case is the left half of the circle. So we could slice a circle vertically or we could slice it horizontally. And for the same reason, that should make sense. This should make sense if the positive is the right side, because on the xy plane, the right side is where x is positive, right? The left side is where x is negative. So one of the things you're going to be asked to do is sometimes they're going to give you an equation and they want you to identify a graph based on like 4 or 5 different graphs. And you should be able to know, right, if x equals some negative stuff, well then it's got to be on the side of the Cartesian plane where everything's negative. So that's why we kind of start out with, here's the xy plane, here's where things are positive and negative. So the graphs in the algebra should always match up. All right, so let's look at the equation of a semicircle that's a little bit more complicated than something quite this simple. All right, does this make sense so far, everybody? Can I see what's going on? Okay. So, one other thing I want to add about not being a function. So, while the circle itself, the original equation was not a function, if you take each of the semicircle equations on their own when you solve for y, if we only look at the top half, well, then that is a function, right? Because if you do the vertical line test, it's only going to cross at once. If I only look at the bottom half, that is a function. But when you put them together, they cease to be a function, okay? So let's look at another problem and try to look at that semicircle. So let's say I have this. So what's the center of this circle? 3, 0, right? The 3 comes out of the x. The center is going to be 3, 0. And the radius is 2. So if I wanted to plot this circle, I could say, well, I need to have the center over here at 3, 0. The radius is 2, so if I count out 2 in all 4 directions, right, this is going to put me at 1, 0. Then we go 2 over here, I'm at 5, 0. Then up here, we're at 3, 2, and then down here at 3, -2. So all I did in all 4 directions was add 2, right? I subtracted 2 on the left, added 2 to go up, added 2 to go right, subtracted 2 to go down. And so if I actually connect, right, all these dots, I'll have my circle. But what I want to do is I want to know what the equation is for the semicircle on top. I want to figure out how do I plot that. So if we solve this for y, all right, so all I'm going to do is get y by itself. So I'll bring the whole term over to the other side. And when I take the square root, even though technically I get 2 answers, I only want the top half of the circle, so I'm only going to keep the positive case. And you can leave it right like that. There's no reason to FOIL that out and simplify. You can just literally move that whole term over, and there's no reason to make it any more complicated. All right, so let's turn it up a notch. Let's find the equation for the left half of this circle. So if we want the left half, are we going to solve for x or solve for y? X, right? Because y gives us top and bottom, right? X gives you left and right. And if you literally think of the Cartesian plane, that tells you your answer, right? If you're solving for things that are above the x-axis, you want to be in the positive y territory or negative y territory. If you're going left or right, you want to be x and x, right? So if we want to solve this for x, all right, first thing is let's get the terms with x's on one side. So x minus 2 squared, right, will equal 9 minus y minus 4 squared. So there is no, and don't do this, there's no need to FOIL this out, because if you FOIL this out, algebraically, it's going to get you nowhere. It's going to get you an x squared term, right, and then another term with an x, and that's going to be really hard for you to do. So what you want to do here, if we want to get x by itself, is we just want to take the square root of both sides. But the question is, do we take the negative square root, or do we keep the positive square root? Negative, because we want the left side of the circle, right? If we wanted the right side, we would keep the positive square root. So here we'll say, well, the square root of x minus 2 squared is just x minus 2. But now what we're saying is the right side of this equation is negative 9, or negative square root of 9 minus y minus 4 squared. So then, to solve for x, we just add 2 to both sides. So the original center of this circle, right, was 2, 4, and the radius was 3. So what we've just come up with, right, is this side of the circle where there's the center. This point up top here, we would add 3 to the y column, so this would be 2, 7. And if we subtract 3 down here, that would be 0.21. And this point over on the side here, we would add 3 because that's our radius, or excuse me, subtract 3. So this would be negative 1, 4. And so if I'm moving in the x direction and I'm going left, that's how I knew I had to take 3 away from the x coordinate to get me in the proper place. If I'm adding 3 for my radius and I'm going up, well, that's the positive y direction, so I added 3 to the y coordinate. When I was going down here, I took 3 from the y coordinate. So if you think about the xy plane, right, whether you're going in the positive x, negative x, positive y, negative y, that's actually telling you whether to add or subtract that value from that coordinate point. Does that make sense? Okay. So that's actually the equation if we were to graph this. And so there's a really awesome graphing utility that I like just because it's really simple and easy to use. There's an app for your phone. You can use it on your iPad. You can use it on a web browser. Some of you probably already heard of this. But Desmos is really great. It's just a graphing utility. It makes very clean, neat, pretty graphs. It color codes things. You can overlay several equations on top of each other on the graph, and it color codes all the equations. You can zoom in and do a lot of cool stuff with it, but it's very simple and easy to use. Makes very clean, neat graphs. So one of the things that I would recommend when you're doing some of these problems is that you open a tab in Desmos and you check yourself by graphing and looking at it, or you graph the original circle, and you can, and one of the cool things about Desmos is you can put your mouse over any part of the graph and it'll show you the coordinate point at that spot too. So you could actually graph this semicircle and actually check that all those points in fact line up. And so it's one of those things that it's good to use when you're studying and practicing, but it's a really, really nice thing. And then another good website that it's not really going to help you guys, it's actually a little bit better for calculus, but when you get into calculus, Symbolab is really good too, because it will kind of walk you through step by step and explain some stuff. But Symbolab is really great, especially for calculus questions when we get into calculus. All right. Sorry, I had another one here I wanted to do. Well, yeah. All right. Here's a good one. Sketch the following. Sorry. One of my former students is on the football team. He's pretty excited. This one, it's an inequality, right? So on the left side, we have what looks like a circle, right? And then we're saying that it's less than 16. So if we want to sketch this, all right, first thing, let's just deal with the left side. Let's try to make this look like a circle. So the first thing we want to do is we want to group the x's and y's together, which they kind of already are for us, but we know we're going to have to complete the square. And so I know this is going to be x plus something squared, and this is going to be y minus something squared. Okay? So I'm going to divide, right? We want to divide the middle term by 2. So when we divide 4 by 2, we get 2. So that means this is going to be x plus 2. And then we square it, right? And you still add it to both sides. So remember the algebra rules for dealing with inequalities. You can treat them just like equal signs as long as you're not multiplying or dividing by a negative number. If you multiply or divide both sides by a negative number, then you have to flip the sign the other way. But otherwise, you can add and subtract all day long and it's fine. And so whatever you do to the left side, we have to do the right side. So the next term, if we divide negative 8 by 2, right, we're going to get negative 4. So we know that's a minus 4. When you square it, right, we'll get 16. So we'll add 16 to both sides. So 16 and 16 are 32, plus 4 is 36. So now what I've got is, this is saying that we have a circle that's less than 36. So what this inequality is actually saying, notice there's not an equal to sign here. If this were an equal sign, we would actually be talking about the points on the circle themselves, right? If this were less than or equal to, then it would be saying we want all the points inside the circle plus the points on the outer edge. But because it is strictly less than 36, we can't include the circle itself. So really what this is it's everything inside the circle, but not on the outside. So this is a circle centered at -2, 4 with a radius of 6, but I only want the points inside. So if I kind of draw a dotted line here. Here's the center of my circle, -2, 4, and really, right? So what this is saying is this is the equation of all the points inside the circle, but not including the points on the circle. Is everybody clear on why we're not allowed to take the points on the circle? Right, because it doesn't include 36, right? If it was less than or equal to, I would have drawn a solid line and shaded it in. If they had said greater than 36, well, greater than 36 means we would have not included the circle, but we would have shaded everything outside the circle. Okay? So when you see an equation like this with an inequality, that's what it's telling you. It's everything inside of something or everything outside of something. And then the question is, do you include the boundary or not? And you'll know whether to include the boundary or not, of whether there's an equal to case. Okay? So this was basically giving you the set of all points inside but not on the circle.
And that's because of the sign, not because of the numbers.
That's because of the inequality sign, yeah. So one thing you want to make sure that you're doing with inequalities, and if any of you, I don't know how much they're going to come up in here. We used to have a lot more in this course, but since we kind of switched books and stuff, I don't know how often it comes up. But if any of you have any issues or just forget how to deal with your inequalities, I have a little lab worksheet that I created that kind of helps people out. But one of the things I tutored this stuff for 15 years before I finally one day it hit me. But one of the things I make students do to me is I'll make them read me the problem. And it's not that I'm being lazy, but I'll dictate the problem on the board. But it's literally one of the things I realize is how you read the problem out loud, because math is a foreign language, is telling me like sometimes what you're not getting. So like if people are reading square root, but it's really a squared, like, you know, and that's like, it's happening silently in your brain, but that's why you're writing it wrong on paper. So I'd write the problem out when they dictate it to me. And one of the things I found with inequalities are students always read them left to right, like they're reading a book. And the problem with an inequality is you don't have to read them left to right. So what they'll do is even if they're reading the x or the y, if they see the symbol going that way, they always read it as less than. And so if I have something like this, students will read that as x is less than or equal to or less than 3 because they see the arrow pointing left. But really what you should do with an inequality is you should go to the variable, and this is saying x is greater than 3. Right? And if I wrote it this way, right, everyone could read that and tell me x is greater than 3, but that is the same exact equation. And so what you want to do is you want to go to the variable and look at how that symbol affects the variable. So everybody had different ways. Like my mom, when I was a kid, she doesn't really know math very well, and so she would be like, oh, it's like an arrow that points to the smaller number. That's what I learned. And then when I got to school, they were all talking about gators, and then, you know, when I got to Georgia, I'm like, we ain't talking about gators. So so I would still say it's the arrow that points to the smaller number. So really, when I read an inequality, I would go to the variable and then read it. So you can read them right to left or left to right. So if you're reading that first one left to right, it would say 3 is less than x, right? But it's also saying x is greater than 3. That's the same statement, right? So if you look at this one that we did here, well, the variables are all here. So it's the circle is less than, like, right, 36, which is r squared. So it's inside the circle. That's how I would read that as. It's the circle, the point's inside, because it's less than. If it had been a greater than, I would have read it out. So it's just one of those things that people just forget how to read and how to graph. So I do have a inequality lab if it's a really helpful little worksheet that I can make available if y'all need it. All right, so we'll stop here for today.